Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Testing for Bias and Fairness in GenAI Models. Testing for bias and fairness in generative AI models is a crucial aspect of the model testing and validation process, essential for ensuring that these models operate equitably and without unintended discriminatory effects. As GenAI models are increasingly utilized in various sectors, from healthcare to finance, addressing bias and fairness becomes not only a technical challenge, but a social imperative. The potential for biased outcomes can manifest in numerous ways, such as reinforcing stereotypes or making unfair decisions that disproportionately affect specific groups. Thus, rigorously testing for bias and fairness is vital to maintaining the integrity and societal trust in AI systems. Bias in GenAI models often originates from the data used to train them. Datasets may reflect historical biases or societal inequalities, which, when not addressed, can lead to models perpetuating or even amplifying these biases. For instance, an analysis of natural language processing models revealed that they often reflect gender and racial stereotypes present in the training data. This is a result of models learning statistical associations from data that may not represent all groups fairly or accurately. In the case of facial recognition systems, studies have shown that these systems tend to have higher error rates for minority groups, which is a direct consequence of training on datasets that lack diversity. Such disparities highlight the importance of curating representative datasets and employing methods to detect and mitigate bias. Several methodologies have been developed to test for bias in GenAI models. One common approach is the use of fairness metrics, which quantify how equally a model performs across different demographic groups. Metrics such as demographic parity, equalized odds, and disparate impact are frequently used to evaluate bias. These metrics allow researchers to identify whether a model's predictions are biased against particular groups by comparing performance metrics like accuracy, false positive rates, or false negative rates across these groups. For example, equalized odds require that a model's error rates be similar across different groups, ensuring that no group is unfairly disadvantaged by a higher likelihood of incorrect predictions. Another critical aspect of testing for bias is the implementation of bias mitigation strategies. These strategies can be employed at various stages of the model development pipeline. Pre-processing techniques involve altering the training data to reduce bias, such as resampling data to balance class distributions or employing data augmentation to increase diversity. In-processing methods modify the learning algorithm itself, often by incorporating fairness constraints directly into the model's objective function. Post-processing techniques adjust the model's outputs to achieve fairness, such as by recalibrating decision thresholds for different groups. These approaches require careful consideration and understanding of the context in which the model will be deployed to ensure that fairness is achieved without sacrificing overall model performance. Testing for bias and fairness also necessitates an interdisciplinary approach, integrating insights from fields such as sociology, ethics, and law. This is because fairness is inherently a social construct, and what is considered fair in one context may not be perceived the same way in another. Engaging with diverse stakeholders, including those from affected communities, can provide valuable perspectives that inform the design and evaluation of fairness in GenAI models. Such engagement ensures that the models are not only technically sound, but also socially aligned with the values and expectations of the people they are intended to serve. The challenges of testing for bias and fairness in GenAI models are compounded by the complexity and opaqueness of these systems. Many GenAI models, particularly those based on deep learning, function as black boxes, making it difficult to understand how they arrive at specific decisions. This opacity can hinder efforts to diagnose and rectify bias, as the internal mechanisms that lead to biased outcomes are not easily interpretable. As such, there is a growing demand for developing interpretable AI models and techniques that allow researchers and practitioners to gain insights into the decision-making processes of these models. Despite the challenges, the importance of testing for bias and fairness cannot be overstated. As AI technologies continue to permeate various aspects of society, ensuring that these systems operate without bias is critical to promoting equity and justice. Moreover, addressing bias in GenAI models is not only a matter of ethical responsibility, but also of legal compliance, as regulations surrounding AI ethics and fairness are increasingly being enacted worldwide. For example, the European Union's General Data Protection Regulation includes provisions that mandate fairness in automated decision-making systems. In conclusion, testing for bias and fairness in GenAI models is an essential component of model testing and validation. It involves a comprehensive approach that includes understanding the sources of bias, employing fairness metrics, implementing bias mitigation strategies, and engaging with diverse stakeholders. By rigorously testing for and addressing bias, we can develop GenAI models that are not only technically advanced, but also socially responsible, ensuring that these powerful technologies contribute positively to society. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.